All right, welcome back. So I've got some time here, so let's knock off some more reading in the Nvidia series. My goal is to basically I feel like a professional skill set should be to get your foot in the door as early as possible, and as quick as possible. So like the AWS cloud practitioner, I feel like that should only take like a month. Now the CCNA, I have a clear sense for how long that should take,
All right.
and I feel like that should take a number of months, at least 3, but even like 6 is probably fair. So I don't know if my expectations are correct here, but anyway, the next video I would be doing is on the Nvidia A100 Tensor Core GPU. Yep. So this will be about 4 minutes. Let's set a timer just to make sure I'm not spending like an hour on something that was supposed to take 4 minutes. I always go over the timer, unfortunately, but just as long as I'm in a general ballpark. All right. So this is the Nvidia A100 Tensor Core GPU. Unprecedented acceleration at every scale. The Nvidia A100 Tensor Core GPU delivers unprecedented acceleration at every scale for AI, data analytics, and HPC, high performance computing, to tackle the world's toughest computing challenges. As the engine of the Nvidia data center platform, A100 can efficiently scale up to thousands of GPUs, or using new multi-instance GPU MIG technology can be partitioned into 7 isolated GPU instances to accelerate workloads of all sizes. A100's third generation Tensor Core technology now accelerates more levels of precision for diverse workloads, speeding time to insight as well as time to market. So we've got BERT large training, BERT large inference, and then another graph as well. So we get up to 6 times higher out of the box performance with TF32 for AI training. So we can see we've got a graph here compared to the V100s, and now there's H100s. So this is a little bit scary because I feel like I'm not studying the latest thing, but we can see the relative performance is 6 times of the V100. And then we get up to 7 times higher performance with multi-instance GPU MIG for AI inference. So when we're doing inference rather than training, we get an additional boost as well in terms of sequences per second. We get 7 times more sequences per second than the V100, and even more than the T4. The T4, this is probably interesting. You could probably get a T4 for pretty cheap. I mean, yeah. So it looks like a T4 you can get for really cheap. So, building your own at home AI, you could do that for $10,000. You could build a pretty powerful home AI system that completely belongs to you. And you get up to 2 times more high performance compute performance. So we can see compared to Amber, Lamps, Fun 3D, and Chroma. For particular applications like molecular dynamics, physics, geoscience, and physics. Now, I'm not sure what this means. There is a footnote on it. It's very unclear 2 times compared to what. I don't see what this line here stands for. So kind of a misleading thing there. But anyways. So system performance, peak performance. So we've got the Nvidia A100 for PCIe. Because remember, it matters a lot. The motherboard, once you plug it in, what's behind that socket when you plug it in? What kind of socket do you plug it into? A good example would be like a SATA versus like an M2. It's not just about the card itself; it's about how the card communicates with the rest of the system. So the socket you use matters a lot, and we can see that the A100 for Nvidia HGC architecture is the same, but where we get a difference is here. We get an interconnect interface, and but it looks like it's, well, let's see here. It looks like it's the same, actually. Yeah, this looks exactly the same. So here's the difference. We can get a power save if we use the PCIe. And I'm at the okay. So whoops, that's taking too long. So let's just see. Put on the stoppage time there. There we go. And then yeah, so you get the full performance, but you do it at a cost of spending extra electricity. So, all right, moving on. Groundbreaking innovations. Nvidia Ampere architecture. A100 accelerates workloads big and small, whether using MIG to partition an A100 GPU into smaller instances, or NVLink to connect multiple GPUs to accelerate large-scale workloads. A100 can readily handle different sized acceleration needs, from the smallest job to the biggest multi-node workload. A100's versatility means AI managers can maximize the utility of every GPU in their data center around the clock. Then we have third generation tensor cores. A100 delivers 312 teraflops, T-flops, of deep learning performance. That's 20 times tensor flops for deep learning training, and 20 times tensor flops for deep learning inference compared to Nvidia Volta GPUs. Then we have next generation NVLink. Nvidia NVLink in A100 delivers 2 times higher throughput compared to the previous generation. When combined with Nvidia NVSwitch, up to 16 A100 GPUs can be interconnected at up to 600 gigabytes per second, GB per SEC, to unleash the highest application performance possible on a single server. NVLink is available in A100 SXM GPUs via HGX A100 server boards, and in PCIe GPUs via an NVLink bridge for up to 2 GPUs. All right. And then multi-instance GPU, MIG. An A100 GPU can be partitioned into as many as 7 GPU instances, fully isolated at the hardware level with their own high bandwidth memory, cache, and compute cores. MIG gives developers access to breakthrough acceleration for all their applications, and IT administrators can offer right-sized GPU acceleration for every job, optimizing utilization and expanding access to every user and application. Then we have HBM2 with 40 gigabytes GB of high bandwidth memory, HBM2. A100 delivers improved raw bandwidth of 1.6 terabyte per second, as well as higher dynamic random access memory, DRAM utilization efficiency at 95%. A100 delivers 1.7x higher memory bandwidth over the previous generation. Then we have structural sparsity. AI networks are big, having millions to billions of parameters. Not all of these parameters are needed for accurate predictions, and some can be converted to zeros to make the models sparse without compromising accuracy. Tensor cores in A100 can provide up to 2 times higher performance for sparse models. While the sparsity feature more readily benefits AI inference, it can also improve the performance of model training. All right, so the Nvidia A100 Tensor Core GPU is the flagship product of the Nvidia data center sound check. Oh, sound is like super high. Yeah, it's like super high. Oh well. Of the Nvidia data center platform for deep learning, HPC, and data analytics. The platform accelerates over 700 high-performance computing (HPC) applications and every major deep learning framework. It's available everywhere from desktops to servers to cloud services, delivering both dramatic performance gains and cost-saving opportunities. So every deep learning framework out there, I'm sure there are more than this. So PyTorch is a big one, TensorFlow is a big one. And then we've got 700 plus GPU accelerated applications. So I don't recognize any of these, unfortunately. And we can learn more here. Now here's that. So the V100 is used as a single SM. Yeah, so okay. So there's some footnote there. But the good news is we're not much more than twice over the expected time. So for me, that's pretty good. All right, so the next one's only 2 minutes. So let's set the timer and go on with that. All right, so this is the NVIDIA Collective Communications Library, NCCL. NVIDIA NCCL. The NVIDIA Collective Communication Library, NCCL, implements multi-GPU and multi-node communication primitives optimized for NVIDIA GPUs and networking. NCCL provides routines such as all gather, all reduce, broadcast, reduce, scatter, as well as point-to-point send and receive that are optimized to achieve high bandwidth and low latency over PCIe and NVLink high-speed interconnects within a node and over NVIDIA Mellanox network across nodes. So this is another one where I don't know how much of this they want me to read. But we've got, so we can download it because it's a library, right? So you can download libraries and use libraries within code, right? So there's probably, so you can download it there. You can also get the source code, it looks like. So we've got the source code here. We can see that it's written in C, actually. It's not written in Python, anything like that. So the documentation will probably make that more clear. Yeah, so here's the documentation. Looks good. So we could watch the webinar. We could let's look quickly at the developer guide. Yeah, that's the same thing here. So this is, if you're working with this thing, please, I beg you, I'll get down on my knees right now. Oh my god, and my knee and my knees are like messed up too. I have like patellar tendonitis, and I'll do it anyway. See how much this hurts? Please, with my hands folded, if you're working with this thing, pull up the developer guide and use that as a reference while you're working with it. Please. All right, now I gotta get back up, which is going to be hard. Okay. All right, I'm back up. All right, and the timer, the timer didn't include bagging in their estimates. So, okay, so one GPU with the NCCL library can turn that one GPU into multi-GPU, multi-node, which can, in terms of performance, NCCL conveniently removes the need for developers to optimize their applications for specific machines. NCCL provides fast collectives over multiple GPUs, both within and across nodes. Ease of programming. NCCL uses a simple C API, which can be easily accessed from a variety of programming languages. NCCL closely follows the popular collectives API defined by MPI, Message Passing Interface. Compatibility. NCCL is compatible with virtually any multi-GPU parallelization model, such as single-threaded, multi-threaded using one thread per GPU, and multi-process, MPI combined with multi-threaded operation on GPUs. And then the key features are automatic topology detection for high bandwidth paths on AMD, ARM, PCI Gen 4, and IB HDR. So different kinds of chip design, as far as I understand. Up to 2 times peak bandwidth with in-network all reduce operations using Sharp v2. Graph search for optimal set of rings and trees with the highest bandwidth and lowest latency. Support multi-threaded and multi-process applications, InfiniBand verbs, libfabric, ROCE, and IP socket internode communication, reroute traffic and alleviate congested ports with InfiniBand adaptive routing. So InfiniBand is one that's probably not going to go away. So if we go to LinkedIn jobs and type for InfiniBand, we'll probably get some hits there, and they'll probably just keep going up. So yeah, we got all kinds of hits we got 612 hits for InfiniBand. So this is probably just going to keep growing. That's a good number of hits. All right, and then if you want to learn more, the documentation, this is another one that's important to look at the documentation. But really, it's that developer guide. If you're going to be working with it extensively, that's really where you need to go. So I'll probably link that to this video. It's right here. It's the developer guide. This will probably be the place to go. Yeah, and then it tells you how to use the API, which you can, so it's really good. All right, so next is GPU communication primitives with NCCL. No, that's what I just read. So the next is the GPT-3. This seems really out of date, which is kind of bad because we're on GPT-4 now, at least with ChatGPT-4. So I feel like I'm reading something out of date. Let me do something really quick here. So I'll reset the timer and I'll set it to 3 minutes. Okay, and then what I'll do is go and okay. So then this is the next thing to read, but I want to look at the about this certification. Yep, and then go look at the certification tab here. And I want to see if because this is the one that's there, so I wonder if that other one is out of date. I think that could be the problem, right? So I wonder if this one has GPT-3 in it, or yeah, okay. So it's the same here. It's not that I'm far behind. I'm getting kind of scared that I'll be studying the wrong thing. As I said before on this channel, I feel like if I had understood, if I had, like the cloud, I feel like cloud kind of passed me by in a way that I'm not really okay with. So I feel like the InfiniBand one might make sense instead of this one. The InfiniBand one looks like it's a bit harder. So, but okay, so I'm pretty happy with what I'm doing now. It's just I feel like there's always room for improvement. All right, so and then I'll link the developer guide here. Yep, this one will be 3 minutes. And I have 3 minutes. I don't have much more than that, so let's see if I can get it done. All right, so OpenAI presents GPT-3, a 175 billion parameters language model. OpenAI researchers recently released a paper describing the development of GPT-3, a state-of-the-art language model made up of 175 billion parameters. For comparison, the previous version, GPT-2, was made up of 1.5 billion parameters. The largest transformer-based language model was developed by Microsoft earlier this month and is made up of 17 billion parameters. Blew it out of the water by a factor of 10. GPT-3 achieves strong performance on many NLP datasets, including translation, question answering, and closed tasks. Closed tasks are like fill in the blank, as well as several tasks that require on-the-fly reasoning or domain adaptation, such as unscrambling words, using a novel word in a sentence, or performing 3-digit arithmetic. The researchers stated in their paper, we find that GPT-3 can generate samples of news articles, which human evaluators have difficulty distinguishing from articles written by humans. Natural language processing tasks range from generating news articles to language translation to answering standardized test questions. So, so we've got the model name here, and then we can see the parameters. Lots of parameters. Okay, so sizes, architectures, and learning hyperparameters, batch size and tokens and learning rate of the models which we trained. All models were trained for a total of 300 billion tokens. Source OpenAI. The precise architectural parameters for each model are chosen based on computational efficiency and load balancing in the layout of models across GPUs, the organization stated. All models were trained on Nvidia V100 GPUs on part of a high bandwidth cluster provided by Microsoft. So really out of date GPUs, two levels behind. Right now we're on H100. Before that was A100, and even before that was the ones these were trained on. OpenAI trains all of their AI models on the CUDNN accelerated by PyTorch deep learning framework. Earlier this month, Microsoft and OpenAI announced a new GPU-accelerated supercomputer built exclusively for the organization. The supercomputer developed for OpenAI is a single system with more than 285,000 GPU cores, 10,000 GPUs, and let's see how much overtime. And 100 gigabits per second of network connectivity for each GPU server, the companies stated in a blog. In terms of performance, the new GPT-3 model achieves near state-of-the-art results on the Superglue benchmark, introduced last year to test reasoning and other advanced NLP tasks. In other benchmarks, including COPA and Record, the model falls short with word in context analysis, WIC, and race, a set of middle and high school exam questions. Despite many limitations and weaknesses, these results suggest that very large language models may be an important ingredient in the development of adaptable general language systems, the organization said. And we have the option to read more, but we're already over time. So yeah, that's it for this one. So yeah, when I come back, we'll very nearly be done with reading that section. We'll be moving on to this one, and I'll include this developer guide at the link here because I beg you, please, I won't get down on my knees again because my knees are sore. If you're working with this stuff, be aware of where this guide is. Use the guide. There's really no better place you can go than the developer documentation, and that's for anything you're working with. If you're working with any tool, go straight to the developer documentation, docs.toolyourworkingwith.com, and get glued into that. All right, so that's the end of this video. Stay tuned for the next one.